unit 2 வந்து என்னன்னு பாத்தீங்கன்னா unit 2 is discrete time system analysis. So this is what your unit 2 is. Okay. So unit 2 corresponds to discrete time system analysis. Okay. So general வந்து இதுல what you'll be seeing, that is the general parameter or the general transform what you'll be dealing with this second unit is nothing but your Z transform. So why you are taking your Z transform? Okay. So what's the relationship between this topic and your Z transform? First you have to know about that. Okay. So as you know, your Z transform will be functioning. Okay. Already you have studied Z transform in your mathematics. Okay, the same principle, same properties only will be repeating over here, but with some uh, different properties with respect to your control system. Okay, so control system, what you have studied will also will be getting repeated over here. Okay, so Z transform, what is the relationship between Z transform and this topic is that, so you have to read the topic, this discrete time system analysis. Okay, so with respect to your Z transform, you will be writing your Z in terms of your omega or nothing but your frequency domain. Okay, so you will be representing your Z transform with respect to your frequency domain. So in turn, your frequency is the reciprocal of your time period. Okay, so that's how these two are interrelated. Okay. So in this unit, what we'll be seeing is we'll be seeing about the properties of the Z transform. Okay. So we'll be dealing with the properties of the Z transform. So after that, we'll be dealing with the some Z transform problems. Okay. Then whatever the properties we have studied with respect to signal or a system will be again repeating in this unit. Okay, this unit, but with respect to a Z transform. Okay. After that, we'll be seeing about stability analysis, okay, frequency response. Okay. So we'll be also dealing with the TTFT transformation also. Okay. So you have also studied about TTFTs. So we'll be dealing with that too. Okay. So now moving on. First, what is the thing you have to know is that you have to know, and yeah, first you have to know about the Z transform. Okay. So what is Z transform? You have to know. Okay. So you just write the heading Z transform. So in general, what you can write is Z transform is, what is Z transform? Z transform is generalization Z transform is generalization of frequency response. So you might have studied about time response and frequency response in your control system. Okay. So you just remember about those. Okay. So in general, the most easy common explanation, what you can write is Z transform this Z transform, each signal, each signal can be, each signal can be represented as, can be represented as linear combination, linear combination, combination of complex sinusoid, of complex sinusoid. ஸோ அப்போ அவங்க என்ன சொல்றாங்கன்னா, இது வந்து ஃபார்முலா வந்து பார்த்தீங்கன்னா, இதுக்கு வந்து ஒரு ஃபார்முலா இருக்கு. Z பவர் n ஈக்குவல் டு ஆர் இ பவர் ஜே ஒமேகா த ஹோல் பவர் n. இதுல வந்து n வந்து பார்த்தீங்கன்னா வில் பி ஃப்ரம் n tends to minus infinity to infinity. So what you have to see is the second point. What it tells is, so by taking the Z transform, in general, what happens is as a linear combination of complex sinusoids. So your sinusoidal wave, okay, your sinusoidal wave will be in this fashion. Okay, right? So this is your sinusoid. Okay? So this will be your time, okay, or we can, the frequency of taking it be omega t. This is a is your signal. Okay. So what they are saying is, if you are taking the Z transform means this is one signal. Okay, this is one signal, and you can take this is A. Okay, this is one signal. This is A, and you can take another one signal. And take another one signal. Okay, this is B. This is B. Okay. So now what happened is, they're saying Z transform is nothing but the linear combination of complex sinusoid. Means you have to sample everything. So draw a diagram like this. It will be like this. It will be represented in this fashion. It will be represented in this fashion. Similarly, the second one also, second signal B signal will also be represented in this fashion. Okay. So this is your x of t. Okay, x of t. Okay, that is before Z transform. Okay, this t before Z transform, while this is your capital X of t after Z transform. Okay.
சார் ஸ்கிரீன் ஃபுல்லா வியூ ஆகல சார்.
So now is this visible, right?
நீங்க இந்த படத்துக்கு மேல ஒன்னு எக்ஸ்ட்ரான்ஸ்ஃபார்ம் எழுதுனீங்க சார், அதெல்லாம் தெரியவே இல்லை சார். இன்னும் கொஞ்சம் கீழே இருக்கு.
Okay, இப்போ தெரியுதா? You will be able to see.
மேல நீங்க மேல டிரா பண்ணிருக்கிறது தெரியல சார்.
ஃபர்ஸ்ட் ஒன்னா?
ஆமா சார். கீழே டிரா பண்ணிருக்கீங்களா? அதுக்கு மேல எக்ஸ்ட்ரா சாங் சொல்லிட்டு டிரா பண்ணி.
Okay, this one, right? இது வந்து சிக்னல்.
அதான்.
This one is signal A. So,
கொஞ்சம் கேமரால கரெக்டா காட்டுங்க சார். அங்க நீங்க எல்லாம் டிரா பண்ணிருக்கீங்கன்றது தெரியல சார்.
okay, now it will be somewhat more visible. Okay. So this is what here is a transformer. Okay. So converting your continuous signal into a frequency response. Okay. So this is given in your frequency response. Okay. So in control system, you might have okay. If it is not visible means I'll after the end of this lecture I'll be taking I'll be giving the same notes. Okay, in the lecture as the lecture notes, you have to see through that. Okay, so we'll be moving on. Okay, so the first thing is you have to know about the different types of filter transform. Okay, so different types you have to know. Type of filter transform. So the first one is one-sided is a transform. So the other thing is two-sided is a transform. So this is nothing but with respect to your axis. Okay. So if it is on either one of the positive or a negative axis means alone means, so the four quadrants, if it is either on this or on this axis means it belongs to one sided. So if it is on both the axis means it corresponds to your two sided. Okay, that's what your one sided and two sided is the transformers. So here you can see a small example. To take it as example one. Example one. Okay. The thing is, for your two-sided is a transform. Two-sided are also known as bilateral. Two-sided or it is known as bilateral is a transform. Okay. Two-sided or bilateral is a transform. So the example is x of z is equal to summation n equal to minus infinity to infinity x of n. So this is not an example. Okay, this is not an example. This is the way to represent your z transform. Minus into n into z minus n. Okay, so this is how they will be representing your z transform. Okay, x of z equal to summation n equal to minus 1 x of n to z power minus 1. Okay, for z transform, this is what it. So you have studied in math, just recall it. Make this one-sided. So one-sided, what is the difference is, you'll be having only one axis. Okay, it will be x of z equal to summation n equal to 0 to infinity, or it can be 0 to even minus infinity, the reverse. Okay, but it will be taking place in only one direction, that for minus 1. Okay, so in general, what happens is, this z transform is accompanied by another one value. So it is called as region of convergence. Okay, so what does this region of convergence mean? Okay, this is ROC of x of z is set of all values is set of all values of z for which x of z attain a finite value. So what is ROC? ROC of x of z is nothing but value of z for which x of z attains a finite value. Okay. So the thing is that the value of z converges at this ROC, at ROC. Okay. That is, the value of z will be within this region of convergence. Okay. So what I am saying is, ROC is a ring, or disk in z plane, with center as origin. So if there is a signal x of n means, we are taking z transform, can I take or you can take inverse Z transform. This is the bidirectional property. Okay, inverse Z transform or Z transform. Z transform is for the forward, the inverse is for the reverse. So getting Z transform means we'll be getting x of Z plus x of Z is what you have seen in the previous thing. It will be unilateral or bilateral plus the region of convergence ROC. So now what you can see is I'll be telling how to find the ROC also. Okay, so you just take out with an example. Okay, we'll be going with an example. So example one. Example one. Given x1 of n equal to a of n u of n. Okay, then x2 of n is equal to minus a of n. Okay, u of minus n minus 1. Okay, u of minus n minus 1. Okay, a of n u of n x2 of n minus a of n into u of minus n minus 1. Okay, so if it is not visible means I'll be just repeating. Okay, you just follow with my audio voice. Okay, so next to find, next we'll be going to the to find Z transform. If they're asking to find Z transform means you always have to find with your ROC. Okay, in general if they're asking to find your Z transform means you have to go also find your ROC. Okay, the solution will be going the solution. So first you put write the formula for the bilateral itself. You just write it out. So x of z is equal to, this is the general formula for your Z transform. X of z is equal to n equal to minus infinity to infinity, then x of n into z power minus n. Okay. So now apply the x of n over here for the first equation for x1 of n. Okay. So x1 of capital Z is equal to summation n equal to minus infinity to infinity. Apply it. So a power n u of n minus z of minus n. So for your unit function, okay, for this your unit function, so for your unit function, your Z transform in general will be, you have already studied. So for the unit function, it will be of form like this. Okay, that is Z by Z minus A. This is a constant. Okay. So for the unit function, if I taking, it will be like this. This is the formula. Okay. If you already studied in your mathematics, so x1 of Z is this. So for finding the ROC, what you have to do is, for finding the ROC, you have to see with respect to your domain. That is, in general, the ROC for this thing will be Z greater than A. So here, why they are taking like this means is A is a constant. Okay. So here, the possibility for convergence is that is n. Here n is there, right? So this n is in here. After this n, there is what you can say. You have to see the axis. Okay, with respect to the axis, you have to see. If you are seeing with respect to the axis means you just take this n value alone. Okay. So if you are taking this n value means apply the wait a minute, I'm having a small doubt in this. Okay, so in general, you'll be finding this ROC like this only. Z minus A is there means will be equating it to 0. This Z will be moving to this side, so it will be A. How it means so this is your with respect to your control system. Okay, so with respect to your control system setting means this is your pole. Okay, this is your pole, and the above numerator will be with respect to your 0. Okay, this is 4 and it will be with respect to your 0. So convergence you have to take it from your pole. Okay, so taking from your pole means so Z minus A will be at this side, okay, and this will be going to that side. Okay, so generally you have to find ROC in this fashion. Okay, but for the second thing, there's a tricky one. The second thing is x2 of Z is will be putting so n equal to minus infinity to infinity. So minus of a power n u of minus n minus 1 into z power minus 10. Okay. So here also you will be getting the same value only. X2 of z will also be the same thing. Okay, same value will be getting. But the thing is that the ROC value gets differs. So the ROC will be uh, less than A. Okay. So this is the procedure for finding ROC for this thing. So for this thing, I will refer and say, okay, I'll just refer with this and I will be saying in the next class. Okay. So the thing is, for both the things, it will be Z by Z minus A, but the only thing is your ROC gets varied. Okay. So I'll be drawing the diagram with respect to ROC, then you will be able to understand somewhat. So properties of ROC. Okay. First thing is ROC of x of z consists of a ring consists of a ring in z plane centered about origin. Okay. Second thing is the ROC does not contain any pole, within it. Okay. So it won't be have any pole within itself, but it will be bounded. So I have been repeatedly saying ROC. So I'll be saying the ROC for the previous one. previous one I'll be saying ROC. What is ROC means in general? So here for x2 of is x1 of z you take the previous one you take x1 of z. So x1 of z you got z by z minus a. So I said for ROC for this will be your modulus of z greater than a. Okay. So here what happens is for this your ROC will be in this fashion. This is your z plane and this is your z plane. So your z is greater than a. So this will be your a. So what it will be a. Okay. That is from origin to the will be a. So greater than a means above this value. Okay. Above this value means I have to draw in this fashion. That is except inside this region, except this inside this region, all the other regions are your ROC. Okay. All the other regions are your ROC. This is for Z greater than A. Okay. But the thing is that over here there won't be any poles present. That is inside the ROC there won't be any poles present, but the poles will be bounded. Bounded means it might be over this line, this circle. Okay. So similarly, for x2 of z we have seen this z by z minus a. So your ROC will be z less than a. So now your ROC will be like this. This is your z plane. So this is your circle. So the again it will be a. So your ROC will be within this region. This is your ROC for this thing. Okay. Z less than a. Okay. You can see the difference, right? The value is same, but your region of convergence differs. Okay. So with respect to this second region of convergence, I'll be saying about clearly in the next class. Okay. So we have seen about the two properties of ROC. So the third property is if if x1 of n is right-sided sequence. Okay. If it is right-sided sequence, then ROC extends extends outward, extends outward from outermost pole. The pole won't be inside, so it will be at the boundary. Okay, so that's what they're saying. It will be extending from the outermost pole to possibly including z equal to infinity. Okay. So this you can see as The casual sequences are right-sided. ROC of this sequence lies ROC of this sequence lies outside the circle. So the best example for this is this diagram. So this is the diagram. This is an example for third point. Okay, example for third point. So it is a right-sided sequence. It's a right-sided sequence. So the fourth point is if x2 of n is a left-sided sequence, then ROC extends inward. Okay. ROC extends inward from innermost non-zero. So in all the conditions, what you have to infer is that the pole will be at the boundary. Okay. Non-zero pole to possibly including z equal to 0. Okay. So as anti-causal sequence are left sided, ROC will rise inside circle. So the best example is this. So the best example is this. So this is your left-sided signal. So this for your 0.4 example. Okay. So next, if 3 of n, another one signal is x3 of n is two-sided sequence, so ROC will consist of a thing in Z plane bounded on interior and exterior and exterior by pole. Okay, so for this thing it will be like this. So if this is your signal mean for two-sided, if this is your x of n means that is P of n after taking zt, so your signal, the ROC will be, the ROC for this will be like this. So the last point regarding the property, if if x of n is a finite duration sequence, then then ROC is, so regarding this finite duration, while doing example, I will say ROC is entire z plane except z equal to 0 or z equal to infinity. So these are the 6 main properties of your ROC. So very important thing when these things are. So now you can see some example, small example. Okay. So given for example 2, given x of n equal to 3, 2, 2, 3, 5, 0, 1. Okay. So here it is clear that all the value of your samples are greater than 1. Okay. So this is what your 6th point refers to. Okay. So that is, if x of n is a finite duration sequence, so it is a finite duration sequence. You can easily say the duration. Okay, because it's having 1, 2, 3, 4, 5, 6, 7. 7 samples are there. Okay, so and the starting signal is this one. This here x of 0. So they'll be giving this in your question. So they have asked to find the Z transform for this signal. Z transform. Okay, so if they're asking to finding the Z transforming, you also have to find your ROC. So ROC also you have to find. So solution. So that is your x of n. So write the formula for the Z transform x of Z equal to summation n equal to minus infinity to infinity x of n z power minus n. Okay. Now if you are taking the Z transform for this means your, the simple thing is your x of z will be equal to, so this is a starting sample. This is your starting sample. So write as such 3 plus, it is a constant one. This is the second thing. So it will be constant. So if we are taking a constant for z transform for a constant means it will be 1 by z. So 1 by z can be written as z power inverse. Okay. Similarly for the second one, plus 2 into z power minus 2 plus 3 into z power minus 3 plus again 5 into z power minus 4. So then it will be 0, okay, plus 0 plus 1 into z power minus 6. Okay. So that's your answer for your z transform. Your x of z will be equal to 3 plus 2z minus 1 plus 2z minus 2 plus 3z minus 3 plus 5z minus 4. 0 will be 0 plus 6z, sorry, plus 1 into z power minus 6. Okay. So now the ROC, what as I have said, so the duration is finite. So you have to take the minimum value. So it will be greater than, so the minimum value after 0 is 1. So this is what your ROC for this. Okay. So this part with respect to your example 2. So with this today's lecture, I will be stopping out today's lecture.